Hello everyone, welcome back. We are in our second part of buffers, and this is talking through how you create a buffer solution using salts, using the solid things that you would find in the stockroom. So let's go ahead and get started. So just to remind you, buffers are solutions where the concentration of the weak acid and its conjugate base are within a factor of 10 of each other. The resulting solution, the buffer solution, resists changes in pH when diluted or when strong acids or bases are added to the solution. And we can find the pH of buffers using the Henderson-Hasselbalch equation. Now the key is with the Henderson-Hasselbalch, you can only use this equation if you have a buffer. This equation is not valid for having a weak acid or a weak base or a strong acid or a strong base in solution. If you are trying to figure out how to find the pH of a weak acid solution or a weak base solution, you need to go watch the chapter 16 videos where I talk about how to do that. And remember, those use ice tables. Okay, so our first question is, what is the pH of a solution resulting from dissolving 1.68 grams of sodium formate? Wait, nope, that's not sodium formate. That is sodium bicarbonate and 3.180 grams of sodium carbonate in enough water to create 100 milliliters of solution. And so what we have in solution, remember when we dissolve our salts into water, whenever we put our bicarbonate into water, it's going to break up into its ions, and so we get our sodium and our bicarbonate. And when we put our sodium carbonate into water, it breaks up into our sodium ion and our 2 of our sodium ion and our carbonate ion. And so this creates a solution where we have a weak base and its conjugate. And so this is a buffer where the carbonate is the weak base and the bicarbonate is the conjugate weak acid. And so because we have both of these in solution, we know that we have a buffer. And so since we have a buffer, we can find the pH by using the Henderson-Hasselbalch. So pH equals pKa plus the log of the concentration of the base, which is my carbonate, 3, 2 minus, over the concentration of the acid, which is my bicarbonate. And so to do this, I have to find the concentration of both of these. And so the concentration of my carbonate is going to be equal to the moles divided by the total volume. And so the moles of the carbonate, I'm working with carbonate, so I have 3.180, let's make that an actual 0 grams. And the molar mass of my sodium carbonate is 105.988 grams per mole. And so I get 0.0300 moles. And so my concentration of my carbonate is equal to 0.0300 moles divided by my total volume, which is 100 milliliters or 0.100 liters. And so this concentration is 0.300 molar. And now I need to do the same thing for my bicarbonate. And so my concentration is moles divided by total volume. And for my bicarbonate, I have 1.680 grams. The molar mass is 84.007 grams in 1 mole. And so I get this is equal to 0.0200 moles. And so my concentration of my bicarbonate is equal to 0.0200 moles divided by my 100 milliliters or 0.001 liters, which is equal to 0.200 molar. And so now I have all the information that I need to plug into the Henderson-Hasselbalch. And so I know that the pH is equal to the pKa plus the log of the concentration of the carbonate over the concentration of the bicarbonate. And I know that the pKa is equal to minus log of the Ka. And if I look up the Ka, this is going to be Ka2. If you're still unclear about how to figure out which Ka to use, please go watch the chapter 16 video about reading the Ka-Kb table. And so the pKa is equal to 10.33. And so the pH is equal to 10.33 plus the log of 0.300 molar divided by 0.200 molar. And so I find that my pH is equal to 10.51. And this makes sense because my concentration of my base is greater than my concentration of my acid. And so I would expect my pH to be greater than my pKa, because we know that the pH equals the pKa when the concentration of the base and the conjugate acid are equal to each other. Okay, so in the next video, I'm going to talk through how to figure out how to make a buffer given a little more realistic sort of question. Generally, we ask to make a certain volume of a certain concentration of buffer using things that we have in the stock room. And so what I'm going to do in the next video is I'm going to give you a recipe and I'm going to ask you to figure out how to make, I'm going to give you a goal and I'm going to ask how to create the recipe to achieve that goal. And so that will be in the next video. Keep watching, keep coming back, and keep coming to office hours and let me know how I can help. Thank you.